Thank you everyone for joining me at Mirantis Labs Tech Talks. I'm Avinash Desireddy. Uh, I'm Solutions Architect at Mirantis. At Mirantis Labs Tech Talk, through Mirantis Labs Tech Talks, we bring in like cloud native topics, use cases, and uh, many more topics around cloud native technologies to educate you all. I'm Avinash Desireddy, and I'm a senior solutions architect and developer advocate here at Mirantis. Today, I'm going to share or talk about Kubernetes cluster guardrails using Open Policy Agent uh, and Gatekeeper. It is helpful to secure the cluster or like protect the clusters with different types of workloads that are going to be uh, published into the cluster. So before we get started, like just a quick disclaimer, just to let you know that all the content that is being shared here is for informational purposes, and uh, any any critical decisions that needs to be made, like there should be additional documentation or additional information that needs to be referred before making a critical decision, like in terms of purchases or uh, things like that. Okay, just a little bit more about myself. As I mentioned, I'm Avinash Desiredi, and I do all things Kubernetes. Currently, I'm responsible for creating technical content for Lens community and building and running the Mirantis labs to educate developers on cloud native topics. And I also work with customers directly on wide range of solutions, such as containerizing applications, deploying and operationalizing the Kubernetes environments, improving application deployment experience with DevOps processes, and defining and implementing best practices, and many more. So, couple of housekeeping items before we dive deep into the session. There is a Q&A panel right on the top of this, like that you can find in your Zoom window. Please use the Q&A questions panel to post any questions that you have, and then I'll be monitoring the both chat window and then the Q&A panel to answer any questions like throughout the session. And I'll be providing the links to the slides and the recording in a follow-up email after the session. With that, let's get started. So here is a quick overview of how this particular talk is structured. First off, we'll start with high-level Kubernetes architecture because it's like the core building block of our discussion. And from here, we'll understand how a Kubernetes object is created, like mainly like the request flow from when a user types a command or like kubectl apply to how an object gets persisted. We'll just look at very high level. We'll not dive deep into it. And from there, we'll talk about like what is policy enforcement, what and then we'll talk about like introduction to OPA, Open Policy Agent, why it is important. And from there, we'll talk about the Gatekeeper, which is an OPA implementation specifically designed for Kubernetes. And then there is like a demo at the end where we will be installing Gatekeeper on a Kubernetes cluster and then applying some policies and see how they run. Another quick reminder, so if there are any questions during the session, please feel free to use the Q&A section or the chat windows to post any questions that you have. Okay, with that, let's dive into the Kubernetes architecture. Like Kubernetes architecture consists of like two sets of nodes, like control plane nodes and worker nodes, which are also like referred to like as machines. Like each node can it be on its own physical machine or a virtual machine? Control plane machines components include like API server, scheduler, controller manager, cloud controller manager, like cluster DNS, etcd, etc. Like those are like the key components that uh, are set in the control plane. And for a worker node or a cluster node, in order to run any workloads, It needs to have a container runtime and a kubelet and a kube proxy. So all these components have its own like individual responsibilities. Like for example, like API server like tracks the cluster state, track state of the cluster components and manage interactions between them. And scheduler like distributes like unscheduled workloads across the available worker nodes. I'll not go through each and everything, but the slide like provides like enough information just to give uh, what each component does. But like critical components are, but these are like the critical components that will be installed to make up an and to form a fully operational Kubernetes cluster. And from there, we'll talk about the object request flow. So any object, like for example, a user will interact with the cluster using APIs or a kubectl or a UI-based application such as Lens Desktop. And what happens as soon as a user, like when a user wants to interact with the Kubernetes cluster? The user uses the Kubernetes API or like the client libraries, and then submits a command. Then the request goes through an authorization phase, which verifies if first it goes to an authentication phase in order to authenticate the user. And if the user is authenticated successfully, then the request goes into the authorization phase to make sure the user is authorized to perform or to create the respective object that is defined in the YAML file. For example, like creation of a pod in a specific namespace, if it is allowed or not, uh, that is like defined. That is defined or that is controlled like, through the authorization mechanism. And from there, there is an admission controller. And admission controller like is like a piece of code like that intercepts like the request to the API server prior to persisting that object in the etcd database. Like only when like the request passes like all these three phases, that's when the object gets persisted. And as soon as the object get persisted in the etcd database, that's when the object that's when like the kubelet from the worker node or like the scheduler from the worker node like picks up the information, and the actual containers or like the pods gets created. And just to like talk a little bit more about the admission controller, like some examples. So by default, like there are like few admission controllers in Kubernetes that are like already deployed in the cluster. Like for example, if a namespace exists or not, that is like an admission controller. Like let's say any we can like deploy and create an object, but when we try to create an object using using Kubernetes object resource specification, the object needs to be persisted in certain namespace, because namespace is the high level abstraction to store the to store Kubernetes objects. So if namespace exists or not, that is verified by admission controller. And there is one other thing called like namespace lifecycle, like which manages the lifecycle of a namespace. For example, if you try to uh, delete delete just the namespace, it needs to delete all the objects within the namespace before deleting the actual namespace. So that operation is managed by the namespace lifecycle. And few other admission controllers are like node restrictions or like default ingress class or default storage class. So uh, so in a Kubernetes cluster, if any of you like worked with the ingress objects, then we need to specify the ingress class depending on the type of ingress implementation that we are using. And since there are like wide range of options, like we need to select. We have an option to set default ingress class. So if a user does not provide the ingress class specification inside the YAML file, uh, or like the object specification when trying to create the object, the default ingress class gets picked up and applied. So how that is done is by how it is done is with the help of admission controller, where it intercepts the object specification and then injects like the default ingress class object, and then further uh, performs the next steps on these. Okay, we'll come back to the admission controller again because uh, OPA, or like the implementation of Gatekeeper is based on this admission controller. Now, for the next step, let's let's understand like what exactly is policy enforcement with like the help of like a scenario. So here in the image, we have like three different teams on the left, or we can also like refer to them as like three different users who are interacting with the Kubernetes cluster. And the platform engineer is responsible for managing the cluster. So let's say user blue, user green, and user red, like they deployed the application successfully on the cluster. But the application, and then like the applications gets deployed successfully on the cluster. But if if each of these teams has to apply certain labels in the cluster, like which are custom labels, because each of these teams belongs to different cost centers, and we wanted to know which cost center that they belong to, like so that platform engineer can easily identify who to which cost center the deployment belongs to, or like to which owner, who is the owner of the application, or if the resource constraints are applied on a particular deployment or a particular pod or not. If a platform owner wants to identify all those things, traditionally, how they are enforced by the platform team is by writing best practices documents and letting all the developers know whenever you deploy, whenever deployment needs to be done, the YAML file should include XYZ values, and it is advocated by uh, so it is advocated with the help of like presentations or like different workshops, and also like doing a continuous auditing, and it's a continuous education that needs to be done with the development teams, which is like a time taking effort. So so we wanted to like have an easy management where like certain policies needs to be defined in the cluster, so that based on the feedback loop that goes back to the developer should be able to enforce the changes accordingly. So so just to explain this like with the help of analogy, uh, like so let's consider like an airport, where like our Kubernetes cluster is an airport, and then like each developer a user got a flight ticket like to fly, let's say, to Chicago. They can since they have a flight ticket, they can just go into the airport and then fly to Chicago. But uh, can they carry everything that they want to the airport and then to Chicago, like in the plane? For example, like any weapons or like any liquids, etc., or like luggage of more than certain size. No, they cannot. And that is something that needs to be enforced, or that is something that is enforced through the policies at an airport, like where airport security ensures certain criteria is met for a passenger to take a flight or to enter into the airport. Similarly, for a Kubernetes cluster, we need to have some sort of a security guard, or I would say like some sort of like policies that needs to be applied. So the so So any deployment that is run on the Kubernetes cluster goes through approved set of you know, up, approved goes to approved set of policies, like setting up resource limits on the clusters, or setting up resource quota on the namespace, like restricting users to use images only from like trusted registries, limiting like node port services, because we don't want everybody to create node port services and then run out of node ports, or having like mandatory labels, like attaching cost center owner to the application, like many more. uh, we have policies, and we should know they needs to be enforced. And here are like some of like the common policies like that I was referring to. And how we can enforce these type of policies on a Kubernetes cluster is with the help of OPA, or there is another tool called Caverno. So OPA and then Caverno are like the two popular tools, like which are like CNCF uh, graduated. I think Caverno might be in the incubating stage. Uh, yeah, I couldn't recall like from my last check-in, but so this is where like OPA comes into picture in terms of identifying, in terms of applying the policies on the cluster. So what exactly is OPA? It's like policy-based control, like for cloud native environments. OPA does not is not only yeah, OPA, it's an open source project. Like it is like CNCF graduated, and it's a general purpose policy engine like that enables like unified, context aware like policy enforcement across the entire stack. We have went through an example of why it is important to apply policies in policies on a Kubernetes cluster, but using OPA, since it is a general purpose policy engine, and we can apply the policies on wide range of tools. Nowadays we are using like in distributed computing, we have like different set of tools uh, that work that work based of a distributed architecture, or like the microservices where different microservices needs to interact with each other, and then there needs to be certain policies enforced in term based on like the type of data, or like the type of communication that is being used for them to interact with each other. So that's why what we need to do is we like without OPA, we need to enforce or create these policies manually at different manual. We need to implement these policy engines in different systems, but OPA generalizes it. So that's where we talked about like the namespace exists. So these are like some of the policies like that we talked about the admission controller that are implemented just within Kubernetes. But what if a user wants like a custom one? And if we go to a different system, um, like uh, like AWS Cloud or Istio, like there might be like uh, different implementations of the policy engine is needed. So the OPA simplifies it with because it's like a general policy engine which takes input and then validates against the policy definition, and then like response back to the user with a decision. And it enforces like admins like control over the system. So it uses a special language or like a new language called like regular language. uh, and The Gatekeeper is an implementation which is a dynamic admission controller uh, that is created with the help of OPA framework. And here is like a quick high level like architecture or like like the end-to-end architecture of how uh, the general purpose policy engine works. Whenever like there's a request, like the service can be a Kubernetes service or like Terraform or Envoy or Istio or SSH. So the service can be anything. It can be plugged in, and OPA supports like a wide range of tools. And I'll show you like the ecosystem that it has with wide range of tools that it supports. So as soon as like the request is received by a particular service, they pass that information to OPA policy engine, and the OPA policy engine based on the input, it and then the based on the policy that was defined in the specific policy engine, uh, it responds back to the service whether the policy is allowed or denied. And based on the decision, the next steps are like the request will be either granted or rejected. How we can enforce policies like specific to Kubernetes. Like I know like OPA is a general purpose policy engine. So let's narrow it down to see how the implementation of OPA is done in Kubernetes. And the project is referred to as OPA Gatekeeper, uh, which is yeah, the project is referred to as OPA Gatekeeper. It's an implementation just for Kubernetes with the help of CRDs to make the life of a platform engineer easy to implement the policies on a Kubernetes cluster. So let me talk about like how does it all work, like the flow diagram. Like the platform engineer like sets up like the gatekeeper, and like that's like the step one, and then converts the best practices, that needs to be implemented on the cluster, like usually that is initially defined in a documentation or documentation. They are converted into policies by defining two different objects called like constraint template and then constraint CRDs. And when a user submits a YAML file to the Kube API server, the request first process, processed by the API server and passed on to admission controller. Further, like the gatekeeper admission controller receives the request, because the way admission controller works is it has the list of admission controllers that the request will go through, and once all the admission controllers are visited, and then once all the admission controllers approves if the request needs to be granted or not, that's when the request uh, will be granted, and then it will be persisted into the cluster. So one of the admission controller that we are referring to here is Gatekeeper. And then the next step is like the Gatekeeper validates like the input with the policies, and then responds back with the decision of whether to allow or deny the request. If it is allowed, the API server then persists the object in etc server, and kubelet does its magic to schedule the pods. If the request is denied, the a nice message can be sent back to the user saying why it is not allowed. So with that, let me show like a quick demo of setting up this particular gatekeeper on a cluster, and then we'll review the configuration templates and then apply some policies in there. Okay, I hope you can see my screen. So I'm using a Kubernetes cluster of MKE distribution, like Mirantis Kubernetes engine here, and just going to look at like the quick stats of the cluster. So I have like 3 nodes which are provisioned in AWS region, and And there is like one master node and two worker nodes. So from here, let's look at the namespaces and the UI that I'm using to access the cluster is called like Lens Desktop. It is nice. It provides like an easy way to interact with the Kubernetes cluster with just few click of a buttons. So let me make sure I don't have any previous implementations of Gatekeeper. Okay, I already have Gatekeeper running, but let me just show you like how a Gatekeeper can be installed or like how a Gatekeeper is installed. It's just through by running a kubectl apply command, we can install the Gatekeeper. So I'm not going to repeat this step because it's just one simple command, and then as soon as we run this command, it will deploy the Gatekeeper controller and controller manager, and then the Gatekeeper audit. So here is like the here is the two deployments that gets created as part of the implementation, and there are like few other objects that it creates. Like secrets, config maps, and then services, which is like Gatekeeper webhook. Now, let's go through a quick. Well, I'm not able to move this. Okay. So let me just go through these steps at a high level. So what we'll do is we'll create a service with we will create a service in the cluster and without any policies in place first, and then we will go ahead and create the policies as a platform engineer, and then we will create uh, we'll recreate the service and see how the policy is enforced. Okay, I'm going to apply the namespace policy. So when I create the service for node port service blue, it gets created. I can just switch to the blue namespace. And when I look at the services, so this is a service which is already created. So let me do a cat to show you the specification of this one. So here is the service, and the service name is Blue SVC Cluster IP, and it has all its other specifications. Okay, the service that I created is Blue SVC node port, which is occupying the node port 33,011, and it got created in the default namespace because I have not provided any namespaces. So the names it got created successfully. But what the policy that we want to enforce is a user should not be able to create node port by themselves or like by default, because because the platform team or as a platform team or a platform engineer, we want to enforce users not to use node ports, and they should only use ingress objects to expose any of their services or deployments to the outside world. So in order to do that, what we'll do is I'm going to delete the existing node port object, and what we'll do is I'm going to apply the policy, and applying policy comes in like two forms. First one is creating a template, and then the second one is creating creating a node port constraint. Once these two are created, let's see what happens when we try to create the service. I'm going to run the same like the previous command, which we used to create the service. So as soon as I create that, I receive an error saying that admission controller, admission, like the request got denied because of like block node port, like not allowed to use node port. It is recommended to expose the app using ingress and then reach out to the ops team at an email. And all this additional custom message is provided by me inside the constraint template. Now let's go through what exactly these constraint templates are, like the two different objects that I've created. So this is the constraint template, which is like gatekeeper specific object. And the name of this constraint template is K8s block node port. And it creates like a dynamic CRD, and like the CRD specification of, or like the name of it is K8s like block node port. And inside targets, like we see a Rego template. So this is the Rego language uh, using which like the decision is made. If we go ahead and then if you are like using a different system other than Kubernetes to and then using OPA to enforce policies, this particular piece will be common. Like when I say common, like the syntactical part of it, or the semantic notion of it, you will see a similar where you'll be importing certain package and then defining certain violations based on like the rules. And there is an interesting uh, project, or like I would say like the website. Let me show you that. OPA Playground to test these policies ahead of time and then work through it. So let me take a quick example of label existence. So this is the Rego snippet, and so this is like the code in order to define a policy where the input the so here this is like a Kubernetes example, and this is a JSON object that that will be sent, or that will be sent to the admission controller, which further will be sent to the OPA. And what we are saying is like for this particular input or for this particular object that is getting created, there should be a label called CC code, which is like the cost center code. If there is no cost center that is associated with this particular object, then deny this. For example, if I just like quickly run a quick evaluation, then it says CC code. Okay, yeah, now it got executed correctly. So when I did an evaluate, then then the object creation is denied with a message saying that every resource must have cost center label. And now let's add this cost center label here and see how the output changes. And this is like the Kubernetes object with its kind pod and then the object metadata. And in order to provide a label called cost center with CC code, we need to add a JSON object here called labels. And here I'm just going to create this label cost center. And then cost center is finance 1, 2, 3, 4. So if I'm using this, and then I'm going to do a quick evaluation again, and now the cost center label exists, but the code is not unified, because the code should always start with CCC code dash the code name, but I'm using finance dash 1232. So the format that used to represent the cost center is not correct. And this is something hard to achieve when we when we put all the best practices or policies in a documentation and asking users to enforce it. So let me just change this finance to cost center, and then uh, finance, and then 1, 2, 3, 4, and then we'll do an evaluation. Then we got then there's no deny object. That means this particular object is allowed because it has like the right specification. So this is like the regular language, and then like it takes like this input and then the output. So all these concepts, like in terms of how the input object is passed to the OPA, and then the decision flow is abstracted with the help of Gatekeeper implementation. So coming back to the node port template that we have created. So here is like the rego. What this does is they like send a violation message if for the input of for the input object which is of type service, and also like service of type node port. Whenever for the service of type node port, send a message like not allowed to use node port, and then why. So here is it. And then going back to like the block node port specification, we need to, so this is the other object that we need to create based on the CRD, the name specified in the constraint template. And this particular constraint applies to all the objects of kind service. So as soon as uh, the service object is seen by the admission controller, then it passes it to this particular or it intercepts this particular request or the constraint request. Uh, so I can like customize this message, and then just to show you like the customization works, to reach out to Avinash at Mirantis.com. So I'm just going to change it. So change it and then reapply the policy on the cluster. Okay, could not be found. It is deleted. So and when I create the node port, it changed the message. So so OPA provides a lot of flexibility in terms of customizing like the feedback loop, and also uh, implementing the policy. Like it provides a lot of flexibility. Like in addition to node port, I can also verify if the port belongs to a certain range, because let's say if we want to enforce the policy only for certain users in the organization, but not the others. We can customize uh, the customize the policy in here, so that the policy gets applied only for certain type of users, or certain type of objects created in a specific namespace. Okay, and there's one other thing I'm like trying to look. So here is like so the gatekeeper like the team, like the community has put together the most common list of policies for a Kubernetes cluster. So if we go into the particular GitHub repository, we can see a library with the list of policies. For example, like allowed repositories. We don't want users to pull the container images from the Docker Hub or like specific registries uh, in, into from specific registries, then we can apply this policy so that the users can use only images from an approved registry. Similarly, like automating service token, like so this is what I have demonstrated, like block node port services. And also we can set up like block wildcard ingress policies, so users don't like provide like random ingress rules, and uh, we can like set up these wildcard rules. And then there is a container request for resource limits. So there is like a extensive list of policies, or most common policies that are applied, but these can be customized according to your organization policies. Like for example, like we looked at like adding cost labels, or like the cost center resources. Sorry, like the labels, like owner, cost center, etc. So with that, let's go back to our demo. Sorry, to our slides. I hope that's helpful. Let me know if there are any questions. Okay, so the next one is so we I was referring to like the huge ecosystem, and here is like a quick glimpse of the OPA community, or the different tools or technologies uh, on which like the OPA works. So there are like different libraries or plugins or extensions, whatever you call it. They exist with these different sort of tools, and we just focused on the Kubernetes admission controller part. But let's say if you want to have a policy uh, on like a Google Calendar, that can be done way, or like a policy on for a user who is SSHing into a specific node. We can create a policy in such a way that user can SSH only during certain times, but not all the time. But without a policy, the user can log in, or if the user has SSH access to a machine, they can SSH into that machine at any point of time, until and unless like there's another type of system that is enforcing those type of policies. So this is like there's like a wide ecosystem which is used to enforce, which can use the OPA open source policy agent and its implementations. So that concludes our session. Please let me know if you have any questions in the chat, and then we'll go through them. Okay, no questions. Hopefully it is all clear. Okay, so that concludes our webinar, or like the tech talk on the Gatekeeper or OPA. And in we have like few other webinars that are coming up, or like the tech talks that are coming up. The first one is about like the observability in Kubernetes using Prometheus, Grafana, and Loki. This is going to happen on 25th of October at 10 a.m. CDT. Feel free to sign up at Mirantis Labs at labs.mirantis.com/events, and we'll dive deep into how to set up Prometheus, like Grafana and Loki, to enable full observability into the Kubernetes cluster. And Team Lens is going to be at KubeCon. Both Team Lens and Team Mirantis is going to be at KubeCon NA in person from August 23rd to 28th. Feel free to join us, like stop by at our booth and grab some swag from us. Okay. Uh, with that, I'm gonna quickly check the chat window one more time. Okay. With that, like Team Mirantis is hiring for several positions. Feel free to check out our careers page at mirantis.com/careers, and apply for the positions that you are interested in, and we'll be happy to consider. And that concludes our tech talk for today. Uh, Please feel free to like reach out for any questions like via my Twitter handle or by responding to the email that you will be receiving with the recording and then the link to the slides. With that, thank you so much. Have a good rest of your day, everyone. Thank you.